EEG can be used to identify biomarkers in a variety of neurocognitive and neuropsychiatric conditions. EEG biomarkers may provide a quantitative measure of disease progression. In this work, we sought to identify resting state EEG signatures that distinguish between Alzheimer's disease and alpha-synucleinopathies, such as dementia with Lewy body and Parkinson's disease dementia. As part of an ongoing study supported by the National Institute of Health, we recruited participants with Alzheimer's disease and Lewy body disease, including dementia with Lewy body and Parkinson's disease dementia. Slowing of EEG, as evidenced by an increase in power of low frequencies, was observed in all patient groups, particularly in the DLB group. Topographical maps of delta band power were compared to healthy controls. Normalized effect sizes of the increase in power were higher in the LBD group. Slowing of the frequency of the posterior dominant rhythm was observed in both AD and LBD groups. The highest normalized effect size for the slowing of PDR was larger in the LBD group. We used the slope on the ascending side of the dominant rhythm in PSDs as a measure of the prominence of the posterior dominant rhythm. We found that the slope-based measures of posterior dominant rhythm prominence were significantly reduced only in the AD group. The power of PDR relative to total power was significantly reduced in the AD group. The spatial distribution of the dominant rhythm was measured by computing the percentage of power in each channel. In the AD group, its posterior dominance was increased. However, in the LBD group, the posterior dominance of PDR was lost, resulting in a close to uniform distribution of PDR power across the scalp. In summary, EEG power at different frequency bands, as well as characterizing the dominant rhythm in the frequency domain, can identify both common and distinct EEG signatures in AD and LBD. In the LBD group, clinical assessment of fluctuations was correlated with slowing of EEG. In the AD group, the MMSE measure of cognitive decline was correlated with the slowing of EEG. Alzheimer's disease and Lewy body disease have both common and distinct EEG signatures. Slowing of EEG is a common signature in both Alzheimer's disease and Lewy body dementia. The relative power and spatial distribution of the posterior dominant rhythm are among distinct EEG measures that differentiate between Alzheimer's disease and Lewy body disease.